Welcome to 5C, it's dividing radical expressions. Some people call this that we are rationalizing the denominator because we're looking at the denominator, and that square root of 32 is an irrational number, or negative 4 plus the square root of 5 is an irrational number. Like if you put it in the calculator, it will never repeat, never stop. That's the definition of an irrational number. So we got to rationalize it, meaning it's got to be like a whole number or an integer. So the things we do. We have monomial denominators and we have binomial denominators. Monomial, an example of a monomial denominator would be something like square root of 5 or 4 square root of 3. Those are monomials. Binomials would be something like 4 plus the square root of 5, or 3 minus 4 square root of 2. What's making the binomial is two terms. So where are my two terms? I have 1, 2, or 1, 2. Terms are joined by additions and subtractions. So first, the first example I have is the denominator a monomial or a binomial? Well, that's a monomial. So then I look at monomial denominators. What to do? We are going to multiply by the numerator and multiply the numerator and the denominator by the radical of the denominator. So the radical of the denominator in this case is 32. So I'm going to multiply by 32, square root of 32. My numerator, when I multiply together, I multiply outside radicals, so 1 times 3 is 3. Multiply inside the radical, so 32 times 2 is 64. And the denominator, 32 times 32. I'm not actually going to do that because 32 times 32 is 32 squared, and square root are going to cancel each other out. So that's going to end up being 3 times 64, square root of 64, so square root of 64 is 8 over 32. 3 times 8 is 24. So after I multiplied, so I totally skip right over that. After I multiplied, then I got to simplify the numerator, simplify the denominator. So we simplify the numerator, it's 24, denominator is 32. You divide by 8, you get 3. Divide by 8, you get 4. So 3/4 is my answer. Okay, that's with monomial denominators. So I'll do a problem or two with monomials. Oh, there's another way. There was another way to do this problem. Let me show you another way. So you could look at the denominator and say, how can I make the square root of 32 a perfect square? By multiplying by what? Well, if I multiply by 2, 32 times 2 is 64. In the numerator, I get 3 times 1 is 3. 2 times 2 is 4. And then I got to simplify. So 3 times square root of 4 is 2. 64, square root of 64 is 8. 3 times 2 is 6. And we divide numerator and denominator by 2. We get 3/4. So that's another way you could do the exact same problem. So now when we have a binomial denominator, so this is a denominator, we have two terms. Now you multiply by, we call it, so binomial denominator, we're multiplying by the numerator by the conjugate. Conjugate means we change the sign, change the middle operation. So we are going to multiply by negative 4 minus the square root of 5. So change. And we're going to multiply the numerator by negative 4 minus the square root of 5. Now when we multiply this, we got to look. We got to be really cognizant of, we have a binomial and we have a monomial times the binomial. So we have 5 square root of 3 times a negative 4. That negative 4 is going to multiply times 5. That's negative 20 square root of 3. And 5 square root of 3 times a negative square root of 5. So 5 times 1 is 5. 3 times 5 underneath the radical is 15. If you would rather do a Punnett square on this, you certainly could. I have 5 square root of 3 and negative 4 minus square root of 5. You get negative 20 square root of 3 and a negative 5 square root of 15. We got to multiply the denominators. That's 2 binomials multiplied together. So typically I'm going to do a Punnett square on this. Just helps organize things. So I have a negative 4 plus the square root of 5 and negative 4 minus the square root of 5. Negative 4 times negative 4 is positive 16. Negative 4 times 5 square root of 5 is negative 4 square root of 5. Negative 4 times a negative 5 is a positive 4 square root of 5. And a negative square root of 5 times a positive square root of 5, think of it as ones here. So it's a negative 1 square root of 25. Look at simplifying. We have like terms, 4 square roots of 5, and we're always think of it as adding. We're adding a negative 4 square roots of 5, which in the end, those will cancel. We have in the bottom right, square root of 25 is 5 times negative 1, so that'll turn into negative 5. We have 16 in the top left plus negative 5 is going to be 11. So the denominator turns into 11. That's a rational number, meaning it can be represented as a fraction. The last step would be to look at each individual term and see if we can simplify anything. The square root of 3 I cannot simplify. Square root of 15 I cannot simplify. And 11 I cannot simplify. Then I look at my coefficients, negative 20, negative 5, and 11. Can I simplify all 3 of those? That's a fraction, and no, I cannot. So this is my final answer. So let's take a look at problem like number 1. And look at the denominator. I got square root of 3. That is a monomial, so I'm going to multiply by the square root of 3. And then what that's going to do is it's going to give me, in the numerator, square root is 18. And the denominator is going to be 4 square root of 9. 18 can simplify into 9 times 2. The square root of 9 is 3. So that turns into 3 square root of 2. In the denominator, 9 turns into 3. So 4 times 3 is 12. Then I got to look to simplify. 3/12. 3/12 simplifies to 1 over 4. So 1 times the square root of 2 is the square root of 2 over 4. 4 is a rational number. It's a whole number, so that is the final answer. Let's look at I'll do number 5. So looking at the denominator, monomial, so let's multiply by it. I have the square root of 20 over the square root of 20. I could have multiplied by like the square root of 5 because that'll give me the square root of 100 in the denominator, and that's a perfect square. I'm going to do this just to keep it consistent, but there are other things you could multiply by. So square root of 20 times 3 is 3 square root of 20. Square root of 20 times a negative 5 square root of 5 is a negative 5. Multiply 5 times 20 is 100. And then the denominator of 20 times 20 is 20 squared, which is 400. The denominator is just going to end up being 20. In the numerator, I got to look at each individual term. Can I simplify the square root of 20? Yes, I can. That simplifies to 3 times biggest perfect square that can divide that 20 is 4. And that's square root of 4 is 2 times 3 is 6. So that's going to turn into 6 square roots of 5. In my second term, I have the square root of 100 is 10 times 5 is negative 50. And in the denominator, that's going to square root, square are going to cancel, giving me 20. And then look, do I have anything I can simplify with my coefficients? 6, 50, and 20 all can divide by 2. So it's 3, 25, and 10. So I get negative or positive 3 square root of 5 minus 25 over 10. That is my final answer. Some of us might be kind of thinking about 5 and simplifying it with 25 and 10. But that is not a 5. That's a square root of 5. And the square root of 5 is like, it's an irrational number. You can't simplify that with a fraction. So that is your final answer. Woo. Sorry. So that is your final answer there. Sorry about that. Let's move on to a binomial, do a problem with that. So when it comes to a binomial, I have two terms here. You can look at them separately as 5 is a term and 4 squared is 2 is a term. What you need to multiply by is change the sign in the middle. Multiply by the conjugate, so that's a positive, so I got to multiply by 5 minus 4 square root of 2. And I'm going to do that in the numerator. 5 minus 4 square roots of 2. I have in the numerator distributed in 5 times 2, or 2 times 5 is 10. 2 times negative 4 is negative 8 square root of 2. In the denominator, typically we use a Punnett square. You certainly could FOIL it, multiply, double distribution. Five times 5 is 25. 5 times 4 is 20, so that'll be 20 square root of 2. 5 times negative 4 is a negative 20 square roots of 2. And negative 4 times 4 is negative 16. 2 times 2 is 4. Look at simplifying. The nice thing about this, when you multiply the conjugate, you'll always get opposites, which will cancel out. Bottom right, square root of 4 is 2. Negative 16 times 2 is negative 32. So negative 32 plus 25 turns out to be negative 7. Now we look at, can I simplify anything in the numerator? No. Can I simplify anything?
Attention in the building. Students, if Myra Diaz Valera, please come to the front office. Myra Diaz Valera, please come to the front office. Your parents are here. Thank you.
Oh, that was nice. We look at 10, 8, and 7. Is there anything there that I can simplify? No, I can't divide them all by anything. The last thing that I'll say is typically we don't keep the negative in the denominator. We put it up to the numerator, and then we distribute it in. What that's going to do is it's going to make it from a positive 10 to a negative. Instead of a subtraction, it'll be a positive 8 square root of 2, and then it'll be a positive in the denominator. That just looks a little nicer. And then I guess the last problem I'm going to do is this cube root down on the bottom here. When we have a cube root, we're looking for what are my perfect cubes. So I got 8, 27, 4 cubed is 64, 5 cubes 125, that's high enough. So 2 times what will give me one of these numbers? Well, 2 times 4 will give me the cube root of 8. And your goal is to get the denominator to be a whole number. And the cube root of 8 is 2, which is great. In the numerator, then, we got to multiply by the same thing to create, what I'm doing is I'm creating something that's equivalent to 1. Anything divided by itself is 1. So I'm not changing the value of this expression. I'm just changing it into a different form that is more user-friendly for us. 2 is on the outside. We have a cube root. 8 times 4 is 32. Cube root of 32 can be simplified to 8 and 4. Cube root of 8 is 2. Cube root of 4. So this is going to end up being 2 cube root of 4. And then we have on the outside 2 divided by 2 is 1. 1 times the cube root of 4 is the cube root of 4. That's your final answer. Hope this helps.